Hi guys, in this video we're going to show you how to sketch parabolas with several techniques that has transformations. Okay. Remember, we're always wanting to refer to y equals x squared. Alright. I'm wanting to consider the example of y equals minus x minus 3 squared plus 7. Now that may look a little bit confusing to begin with, but as we just unpack it bit by bit, step by step, you'll realize that it's to make certain observations. It actually is not that difficult. Okay, so what we know is that it has a negative in the front. Okay, discussed earlier that this negative refers to an upside down or inverted parabola. Okay, we also know that that value over there is going to be your vertical translation. So moving up or down the y-axis. The last thing is the actual 3. Okay, so ignore the negative. This is your horizontal translation. That value is going to show you how far to the right or how far to the left that the parabola will actually move in comparison to y equals x squared. So firstly, this is going to be an inverted parabola, upside down. It's going to be 7 units up the y-axis, and it's also going to be 3 units to the right. So let's have a look at just a quadratic rule that could actually help you guys. Okay, so if you look at this, I'm going to be replacing certain numbers with pronumerals. So y equals x minus h, okay, squared plus k. I'm going to put a plus or minus a in the front, okay, because the a is your dilation, okay. The positive or negative value is going to be more the direction, okay, whether it's going to be the right way up or whether it's actually going to be inverted. All right. As mentioned before, the h is your horizontal translation. Notice that I've circled the h, not the minus sign, because we're actually talking about the letter, okay? And then lastly, the value for k is going to be your vertical translation. So moving up or moving down. Okay, now just in terms of the translation side of things, I'll just add to this part here. If h is greater than 0, okay, so exclude the negative, okay, we're just looking at h on its own. If h is greater than 0, so 1, 2, 3, etc., it's going to be moving to the right. Okay, so notice that we have a 3, so that means the parabola is going to move 3 units to the right. If h is less than 0, so we have -1, -2, -3, etc., it'll translate to the left. Oops. There. Now, this is where the negative comes into play. If we have, say, h is -2, so negative 2 is going to be a positive 2. Alright, so that's why if I showed you a previous, so just looking here, you may have been a little bit confused, but that's alright. We have an x plus 3, and that moved to the left, and the x minus 2 moved to the right. But then you think, but the negatives is going kind of left and positive should go right. It just kind of makes a little bit more sense that way. But 2 negatives makes a positive. Okay, so -3 is going to move to the left. Alright, so have a look here. If h was -3, minus -3 is going to be a +3, which is what we have here, and that is why it moves to the left. Whereas if h was +2, minus and a positive is going to be still a negative, and so -2 will translate it to the right 2 units. Okay, so going back here, moving on to the letter K, it's going to be if K is greater than 0, okay, then it's going to go up. If K is less than 0, then it's going to move down. Okay. The last thing that I want to talk about is the turning point, or the vertex. By looking at the equation here, you can actually identify where the turning point is by looking at the equation. Okay, so the turning point is going to be found by hk. So the values of h is going to be your x value, and the value for k is going to be your y coordinate. Okay, I'll show you very soon. And then the axis of symmetry is x equals h. It's going to be the same value for that. So let's put that into practice. hk, the value for h here is a 3. So I'm referring to this example on the top. And the value for k here is a 7. Okay. So that means when x is 3, y is 7, that is going to be my turning point. Okay. We know that it's going to be upside down, so it's going to go down like that. This is my axis of symmetry, so x is h. Okay, axis of symmetry is, you don't have to draw the dotted line, but just to make the point that just makes sense that the axis of symmetry is the same point of the turning point. Okay, now the last thing to do is to work out what the x-intercept or the y-intercept is, but basically the y-intercept is going to be found when x is 0. Okay, so let's do that. Let's identify the y-intercept. Found when x equals 0. So let's substitute 0 for x. So we have y equals minus x minus 3 squared plus 7. Okay, so if x is 0, then we have 0 minus 3 and squared. Minus 3 squared is going to be 9. Okay, minus 9 plus 7 is going to be minus 2. Okay, so here's your y-intercept. Your y-intercept is going to be at 0 minus 2. So when x is 0, the y-intercept is going to be there. Okay, so let's have a look at what this parabola looks like so far. Okay. Here's your turning point. It's going to go down, and then it's going to cut the y-intercept or y-axis at minus 2. What we don't know yet is where it cuts the x-axis. And simply to find out the x-intercepts, it's going to be when y equals 0. So what we'll have a look at, it's going to come down and then go down there, and then if that is your axis of symmetry, then roughly it'll go down like that. And these points is something that we will find out a little bit later. But this is just going to be a rough sketch. We'll move on to just looking at some really basic and simple steps of sketching. Okay, so we're going to move on to just sketching parabolas in a very simple manner. We're going to start off with y equals 3x squared, but I also want to just write down the formula again, where we have y equals plus or minus a, okay, x minus h squared plus k. Alright, notice that if we remove the value of h, then you will have, so if I just block it there, you will have x squared. Alright, so here we have x squared. There is no h, there is no k. There's nothing left over there. So when we're talking about the turning point, the first thing that we can identify is that the turning point is going to be at 0, 0. So remember, with y equals x squared, our base parabola that we try to refer everything to, the turning point is at the origin. So this is going to be the same. The coefficient, okay, of x squared is going to be the number that determines how dilated the parabola is, how wide or how skinny. Because this number is larger than 1, because the coefficient of x squared is 1, it's greater than 1, it's going to be a lot skinnier than y equals x squared. So that's another one that we know. So we know that it is going to be skinnier than y equals x squared. Well, that is pretty much all we can find out. We do want to find out what the y-intercept is. So what we can do is, substitute 0 for x, but then anything multiplied by 0 is just 0. So the y-intercept is going to be 0. But the last thing that we wanted to do is to find a second point. Okay. Substituting x with 0 is not really going to help. We know it's going to hit that point there. So let's substitute x for 1. Where will y occur when x is 1? So if x is 1, so let's sub 1 for x, okay, into equation. So if x is 1, 1 squared is just 1. 1 times 3 is 3. So when x equals 1, y equals 3. So let's put all of these points that we've just discussed into the graph here. We know that the turning point is there. We also know that the y-intercept is at the same point, so that doesn't matter. But we also know that another point occurs when x equals 1, y equals 3. Okay, so if we join the dots together, we know it's going to look something like that. And because this is your axis of symmetry, then we can safely say that you're going to have another point there, and it's going to look like that. Okay, so very skinny, and we have a second point there with your turning point there. All right, let's move on to another example where we have y equals negative x squared plus 4. All right, so if we have a look at this, the value of a is negative 1. So we know that the first thing that we already know is that because this is a negative value, it's going to be inverted. It's going to be an upside down parabola. The other thing we know is look at the 4, which is representing k. We know that it's going to be, I'll put a v for vertically. So vertically translated 4 units up. Okay, so if this is x, negative x squared there, it's actually going to move 4 units up. Okay, so that means that the turning point is going to be at 0, 4. Okay, so remember the turning point is found as, I'll put this over here, as the value of h and k. Now with this equation here, there is no h, so we can assume that h will equal 0, and then the value for k is 4. So our turning point is going to be here. Okay, so there's our turning point there. We know it's going to be inverted, and yes, it's being translated 4 units up. Okay, so now all we need to do is find a second point again. So how we do that? So at the moment, we're not really worrying about the x-intercepts. Okay, so find the second point by substituting 1 for x. So let's have a look at this. So when x equals 1, we have 1 squared, and it's a negative 1. Okay? So if x is 1, then 1 squared, and it's negative. So negative 1 plus 4 is going to be 3. So y will equal 3 when x equals 1. So this is going to be our second point. When x is 1, y equals 3. Oh, got a bit of a conflict here. So let's do that. Okay, and let's do that. So that's going to be our parabola going down with our 2 points. Alright, let's do another one. So rewriting it here, plus or minus a, x minus h squared plus k. We know that the turning point is at the coordinates of h and k. Let's have a look at this example. What shall we have? Y equals x minus 2 squared. Okay, so the coefficient of x squared, this value here of a, is just 1. It's positive. We know now it's going to be a smiley face. So right way up. That's one thing that we know. We also know that there is no k. Okay, so we can safely say that the turning point, if we're looking at h and k, the turning point k is going to be 0, and then h is going to be, remember, ignore the negative there, h here is a 2. Okay, so referring to this, looking at the components, being able to match the 2, there's a 2 for h, and then k, because it's non-existent here, it's a 0. So our turning point is going to be 2 and 0. So let's actually mark that on the graph now. So when x is 2, that's going to be our turning point right there. What we also know is this 2 is showing you the translation horizontally. So let's put this down. H translated. So H for horizontal. Horizontally translated to the right. Okay, so it's going to move 2 units to the right in comparison to y equals x squared. Alright, the last thing is to work out what maybe the y-intercept is. So the y-intercept is found when x equals 0. So let's substitute x for 0. So if x is 0, we have 0 minus 2. Yep. So 0 minus 2 is minus 2. Minus 2 squared is 4. So when x equals 0, y equals 4. So when x is 0, y equals 4. We know that this is going to be our axis of symmetry at the turning point. So we can say that the parabola is going to look like that. Okay. Now, another example is actually to show you via using the turning point. Let's have a look at what that looks like. Okay, so let's use these two examples. Call it D and call it E. So y equals x minus 3 squared minus 2. Okay, remember the turning point is at the values of h and k. So the value of h is a 3. And the value of k is minus 2. Okay, so this turning point for D is going to be at 3, negative 2. 3, negative 2. So that's going to be a turning point. What you can then do is find the y-intercept. Okay, so the y-intercept is, remember, when x equals 0. So let's substitute x with 0. 0 minus 3 is just minus 3. Minus 3 squared is 9. 9 minus 2 is 7. So the y-intercept when x equals 0, y will equal 7. Okay, so 7 is up here. Let's put it in green. So we have our y-intercept, we have our turning point. Let's see if I can do this in one go. Our graph is going to look something like that. With this next one here, do exactly the same thing for E. I'm going to use y equals minus x plus 1 squared plus 4. Okay, so let's start off with our turning point. Is going to be the value of h and the value for k. So k will be a 4. Now the thing with h is because it's plus 1, it's always a really good trick just to remember to invert the positive to a negative, okay? Because negative 1 gives you your positive 1. So our turning point is when x is negative 1, y equals 4. So that's going to be our turning point there. What we also know is that that value in the front is negative. So we can find out, or we can already say that this parabola is going to be inverted upside down. The last thing is find your y-intercept. Okay, so let's find the y-intercept. So the y-intercept is when x equals 0. So let's substitute that in. 0 plus 1 is just 1. 1 squared is 1 again. It is a negative 1. So negative 1 plus 4 is 3. So when x is 0, y equals 3. So our next point is there. That's our y-intercept. That's our turning point. Our parabola is upside down. And it's going to look like that. Okay. Okay, in this last part of this video, I wanted to show you how to find the rule or the equation of the parabola. Okay, so this is all on the basis of y equals plus or minus a x minus h squared plus k. Okay, so k was your vertical translation, h was your horizontal translation, and a was how dilated, how wide or skinny your parabola is. The positive or negative is going to determine whether it's going up or whether it's going down. And remember also, very handy, that your turning point or the vertex is going to be the coordinates of h and k. Now here is a graph or a parabola, and that I need to find out what the equation is for. This point here is at 0, 1, and then this point here is at 1 and 2. So we have two sets of coordinates. This one here is my turning point, okay? That's my vertex right there. So remember, the turning point is the values of h and k. So what I can do is, with the turning point, is substitute these values into this equation. So h equals 0 and k equals 1. So let's substitute it and see what we have so far. We have plus or minus a, okay, and we have x minus 0 squared plus 1. Okay, looking at this graph, it is a smiley face, it's the right way up, so we can automatically know that it's not going to be a negative symbol. X minus 0 is just x. Okay, so what we have so far is y equals x squared plus 1. Okay, so what we need to do is actually find out find out what a is by substituting the values of 1 and 2. So next step, find value of a, substitute second set of coordinates. And in this case, our second set of coordinates is 1 and 2. Okay, x is 1, y equals 2. So let's substitute it into here. Y equals 2. So 2 equals a, x is 1. So 1 squared is just basically 1. So a times 1 is just a. And we have plus 1. Okay. To get rid of the positive 1, we carry it over to the other side. So a equals 1. Okay. So now what we have is y equals, we're going to substitute that in there. A is 1. We have x squared plus 1. So we don't need to really write that number 1 in there. That's our formula or equation for that graph. And if we have a look at it, it does look like y equals x squared, okay, but it's been translated vertically, so it's moved up that y-axis by 1 unit, and this value of k, positive 1, has shown that it's moved up 1. Okay, see you later.